The Flex4RES project analyzes flexible Nordic and Baltic energy systems. This video presents the results for Finland. Looking at the key findings for Finland, relatively stable development is seen across the scenarios. The exception is that additional investment in transmission in the Connect scenario results in an increase of wind capacity between 2030 and 2050. Changing the current regulation towards capacity-based grid tariffs and taxation leads to an increase in power-to-heat capacity. This increases generation from power-to-heat by 16% or 5.6 terawatt-hours and corresponds to half of all heat generation for district heating. Heat storage is expanded considerably by up to 300 gigawatt-hours, mostly represented by seasonal storages. For all scenarios, we see a Finnish electricity supply share of 42% supplied by wind and solar, a reduction in biomass and biogas, and a reduced share of nuclear power. And now let's have a look at the results. We start out in the electricity sector. The striking part about the Finnish scenarios is their similarity. One significant exception is the wind capacity addition in 2040 as a consequence of the additional transmission capacity. On the generation side, the similarity is naturally also evident. The increased wind capacity in the Connect scenario temporarily leads to relatively larger generation until all scenarios converge towards 2050. And now let's look at the heating sector, where there is a bit more variation among the scenarios. Changing the current regulation towards capacity-based grid tariffs and taxes, power-to-heat capacity increases with between half and 1 gigawatt more capacity than business as usual for 2030 to 2050. And all but the business as usual scenario leads to increased shares of biomass boilers, meaning that increased interconnection and revised taxes and tariffs drives installation of both power-to-heat and to some degree boilers. Regarding fuel use, the Combi scenarios shows the least use of biomass for heating throughout the analyzed period. Instead, heat is based on electricity. And finally, let's look at storages. As mentioned in the beginning, the deployment of heat storages is considerable. Already from 2030, we see a large deployment of especially seasonal storages. In the Combi scenario, the deployment of seasonal and short-term storages finds a level in between the Connect scenario's large amount of short-term storages, which allows for short-term cycling of plants, and the policy scenario's considerable deployment of seasonal storages. You can find similar videos with country profiles and recommendations the same place you found this one. For even more details, have a look at Flex4RES.org.